Today we're going to be rationalizing the denominator. This is just like you put a capital letter at the beginning of a sentence. This is a rule that you have to do. We do not like radicals in the denominator of a fraction, and so you have to rationalize it, which means multiply by another root so the root in the denominator goes away. The whole goal is to multiply by something so that we get a perfect that can be evaluated. So here we have square root. So if I multiply by another square root, then that square root on the bottom should go away. So we'll multiply by the square root of 5. When I multiply straight across, I get 3 root 5. 3 is not in a root, and so it has to stay outside. Times the square root of 5 times square root of 5 is square root of 25. And so that would get me, now we'll evaluate it or simplify it one more time. You get 3 root 5 over the square root of 25, which is 5. This one is a little different because it's a cube root. So we'll first start by splitting it up into the cube root of 6 over the cube root of 5. And now we're going to try and rationalize it if we do the same thing as we did last time. So if we go ahead and rationalize this like we did the last one and start by just saying, okay, I want to multiply by the cube root of 5 on the top and the bottom. Here's the problem. If I do it like this, I'm going to end up with the cube root of 25 on the bottom, which would be great if it's a square root, but this is a cube root. And 25 is not a perfect cube, because remember, we're looking at cubes. Sorry. Okay, so we've got 5. What we want to do is make sure we have a perfect cube. Here's how we do that. We make sure we have 3 5s. Right now I have 1, so I need to multiply by 2 more. Have 1, need 2 more. So that's why we multiply by 2 more right here. Over here, right there. And make sure to multiply that on the top and the bottom. So the cube root of 5 squared. If I multiply on the top and the bottom by that, I've got the cube root of 6 times 25 on the top. And on the bottom, I've got the cube root of 5 to the 3rd. The whole goal is try and get a perfect cube or perfect whatever you have so that you can evaluate it. So now when I multiply these, 6 times 25 I think is 150. So the cube root of 150 over, all right, you could think about this a couple ways. If you would rather, you can actually figure out what number that's going to be. Like if I do 5 to the 3rd power, anyone know what that's going to be? 5 to the 3rd is 125. So that's obviously a perfect cube. And then the cube root of 125, which you can use your chart, is 5. That's one of the options. Another way to think about it is when I have the cube root of a cube, those cancel out. So this cube root and the cube go away basically, and all you're left with is 5. We always check and see, okay, this top number, 150, that's a cube, or that's a cube root. So is there any perfect cubes? Check your list. Is there any perfect cubes that 150 divide by? So your only options would be 8, 27, 64, 125, and none of those work. So no. So you are done. So you check and make sure, see if it can simplify. If not, then that's all you can do. The fifth root of 7 over the 5th root of 8. Okay, you could be like, okay, well I have 1/8 to be a perfect fifth. How many more would I need? I need 4 more. Here's the thing, you're going to get really big numbers if you do that. If you multiply like 8 with like the fifth root of 8 to the fourth, you're going to have really big numbers. So we would want to look at this and try and make it a little bit, the numbers a little bit smaller. Look here at 8. What do you know about 8? 8 is a perfect cube. Yeah. So since 8 is a perfect cube, when I see a perfect, so we're going to make notes on this. Take good notes today. Please notice that 8 is a perfect. It's not a perfect fifth, but that's okay. Anytime I see something that is perfect, I'm going to try and break it down so that the numbers are a little bit smaller. The cube root, so you know it's a perfect cube. What to the third power is 8? It's 2, right? So we'll rewrite it now. The fifth root of 7 over the fifth root of, not 8, but 2 to the third, because 2 times 2 times 2 is also 8. So what we're trying to do is, I know 8 is perfect. I'm going to try and break it down so that my numbers here are not so large. If you miss that and totally skip over it and just multiply by the fifth root of 8 to the fourth, it's not a big deal. You're going to get the same thing. Or like at the end, you're just going to have to do a lot more simplifying, okay? Bigger numbers. Okay, so on this one, you have, let's see, 2 to the third. You're trying to do perfect fifth. So how many more 2's do I need? If I have 2 to the third, I need how many more? 2. So you're going to multiply by the fifth root of 2 squared, because then I would have 3 plus 2, 5. And make sure you do that on the top and the bottom. All right. I'll do it on the next row down. So that would get me on the top. I've got the fifth root of 7 times 2 squared, which is 4. And in the denominator, we've got the fifth root of, we should have 2 to the fifth. That was the whole point of doing that, was so that I have something I can actually evaluate. You could do this with your chart and think, okay, 2 to the fifth power is, I think 32, right? 2 times 2, yeah. 32. And the fifth root of 32 is 2. You can think of it like that, or you can think of it like these are going to cancel each other out. It's going to leave me with 2. So on the top, I've got the fifth root of 28 over just 2. You should always check the numerator and see, okay, that root that I have, is there any perfect fifth that 28 divides by? No, because the first one besides 1 is 32, and that's bigger than 28, so no. What do you think you should do first? Do you guys notice anything here? 4 is perfect, right? It's a perfect square. It's not a perfect fourth, that's okay, because we're just trying to make the numbers a little bit smaller. This one is actually one it's not so bad. 4 is a pretty small number, so if you were to ignore that and just do like, oh, I have 4 to the first, multiply by 3 more, that's fine. We're going to break it down though. So 4th root of 3 over 4 is the same thing as, what is the, so it's a perfect square, so what squared is 4, yeah? 2, right? 2 squared. So I could rewrite it like that. That means my numbers will be smaller. I have to simplify less at the end. That's the perk there. Okay. You have 2 2's. To make it a perfect fourth, you need how many more? 2. So we multiply by the 4th root of 2 squared. That way we have 4 of them in a second. And make sure you do that on the top as well. 4th root of 2 squared. Hold up. Okay, I'm just making sure the last one right. Okay, so you get, let's see, what do we have on the top? That would be the fourth root of 3 times 4, because 2 squared is 4. At the bottom, we have the fourth root of 2 to the fourth. So the fourth root of 12 over the fourth root of 2 to the 4 would be just what? You could think of it in terms of, if you want to figure out what that is, that's 2 to the 4th power is 16. What's the fourth root of 16? It's 2. That's always going to happen. It should happen if you have fourth root of 2 to the 4. If your exponent matches your root, then they cancel each other out and you're left with just the number underneath. So you have some examples. X plus y, x minus y. 1 plus root 3, 1 minus root 3. Square root of 5 minus root 7. Square root of 5 should be plus. And square root of 5 plus root 7. Haha, typo. Okay. These are all conjugates. A plus b, a minus b. We've done it before. It's like the same thing but a different sign. You've seen it before with difference of squares. If you want to use the trick to remember how to multiply these out, you certainly can. I am not going to do that today because I'm just terrible with that kind of stuff. I would rather just multiply it out and see that same pattern happen every time. If you want to memorize the rule of what's going to happen, great. But I will not show that way because that's not why it happens. That's a pattern that happens, okay? That I think you'll catch on to more if we actually just do it. So look at number 21. I have 5 plus root 3, so I'm going to multiply by 5 minus root 3 on the top and the bottom. This is called the conjugate. It is the same thing, but a different sign. And you were just distributing. So on the top, you'll see I'm just going to, we'll go ahead and put these in parentheses. And this guy too. So anything with 2 terms, I'll put in parentheses. The 1, not necessary. Okay, we'll distribute 1 times 5, 5. And then you're also going to do 1 times the square root of 3. Sorry, 1 times negative square root of 3, so that's just negative square root of 3. So that changes nothing. In the denominator, you are going to distribute. This is FOILing or double distributing, whatever you want to call it, right? First, outer, inner, last. So we'll start by distributing. I'll do this in blue. Distribute the 5. So this is a part of your test we do really well on. 5 times 5, 25. Now you do 5 times negative square root of 3. Okay, 5 is not in a root and 3 is. So you cannot multiply those together. It's just going to be negative 5 root 3. Now we're going to distribute the root 3. Positive square root of 3 times 5 is positive 5 root 3. And then the last thing we'll do is square root of 3 times negative square root of 3, which is negative square root of 9. Okay, I should have made my bar bigger. Do you see what's going to happen? These middle terms, negative 5 root 3, positive 5 root 3, they cancel each other out and they add to 0, which means they're gone. And you are only left with those outer 2 terms, a squared minus b squared. So again, you can memorize a pattern and do that. If you'd rather just multiply it out and know like, okay, we'll know I've done it right if these middle 2 cancel out. So then you're left with 5 minus the square root of 3 over 25. What's the square root of 9? 3. So now simplify it one more time. It's just like reduce, 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 right? So 5 minus the square root of 3 over 22. We do. All right, I heard it. You are with me. Square root of 2 plus the square root of 6 on both the top and the bottom. Okay, let's put that in parentheses since we're distributing. If you feel like you can do this on your own, you can do it without me, but we're going to go ahead and distribute the top. I'll do that in black. So when I do 3 times the root 2, I get just 3 root 2. And 3 times root 6. Do I multiply the 3 and the 6? No, I don't multiply to get 18, right? Because 3 is not under the root, so it's just 3 root 6. And now we go to distribute the bottom. Make sure you do first, outer, inner, last, or make sure you multiply both things twice. So square root of 2 times square root of 2 would get me a square root of, you can multiply those, 4, right? Square root of 2 times positive square root of 6 is positive square root of 12. Negative root 6 times positive root 2 is negative square root of 12. And then lastly, you've got negative root 6 times positive root 6, which is negative root 36. Did we do it right? Okay, you will know you've done it right if these cancel out, because you should be left with a difference of squares when you're done. So to simplify that, you've got, right, rewrite the top. What's square root of 4? 2. Square root of 36 is 6. So you got 2 minus 6. Remember, it's got this minus sign right here. Don't lose it. That's where that comes from. Okay, so your final answer is, I know this is so epic, keeps going, 3 root 2 plus 3 root 6 over negative 4. These might take a little bit longer, but the actual thinking behind it I think is a little bit easier than maybe what we did on the previous page. It's just operations and multiply now, okay?